In 5, 4, 3, 2, 1, go.
Right, so all modern engines, well pretty much all of them, work on the expansion of a working fluid. Now the easiest way to get it to expand is to heat it. And of course we can choose where to heat it. So an internal combustion engine is where we burn it inside the piston. It's heated inside the piston. Creates a hot gas, and that gas expands, and we see that as movement of the wheel. But of course you don't only have to burn it inside the engine, you can burn it outside of the engine, which is exactly what things like the Stirling engine and the steam engine are all about. You burn outside, create a gas that wants to expand, feed that into the piston, and the expansion and work is done in the piston. And that's the difference between an external combustion engine and an internal combustion engine. But of course, they're not the only kinds of engines. Any gas that can expand is going to be able to be forced into a piston and do work, which is what compressed air engines are all about. We take a compressed air which just wants to expand, feed it into a piston, and it's going to do that job. So expansion of a working fluid is the main motive power for engines. Now, you can bet your bottom dollar that if you can burn something and get it to expand over history, that is exactly what's been done. And there are some engines that are quite confusing, where it's not evident really whether the expansion of the working fluid is because of its pressurization, or because it's been burnt outside, or because it's been burnt inside. So for example, the ethanol engine. The ethanol engine was a particularly old engine where a tub of ethanol was heated by some outside source, which could be a fire, which could be the sun, and that forces the ethanol to vaporize and expand, and that vapor was fed into the engine, and it was the power of the expansion of the ethanol that forced the piston to work. Nowadays, of course, we put ethanol in the engine and burn the ethanol, and it's the burning and then resultant expanding gas that cause the engine to work. The earlier ethanol engine was a bit scary actually, because of course once the ethanol had done its work of expansion, it was exhausted as ethanol fumes. So you may have got a little bit merry, but you certainly didn't want a cigarette around. If there is any fuel that is perhaps most inappropriate, it's got to be acetylene. Now acetylene is something we use for welding, so there's a degree of familiarity with it. Unfortunately, acetylene has the property of exploding quite violently if you increase the pressure above 20 psi, which it promptly does. It also forms something called copper acetylide if it actually goes through brass or copper pipes. Copper acetylide is a percussive explosive, so when it's dry, if you give it a little tap, it'll explode. So it's not the safest of materials to be using, but it had a degree of popularity both in an expansion engine and in burning the acetylene under a diesel compression ratio. Now acetylene engines went through a lot of development despite the inherent dangers of acetylene, because it was a very promising material that could be made from coal and limestone and water. Of course, during the wars, particularly the Second World War, particularly in Germany, who were resource scarce, alternative fuels were very important, and a whole range of acetylene engines were developed for running automobiles, and the Panzer Mark V tank was produced in 1944, which ran on acetylene. Now, acetylene as a fuel isn't dead. The last reported acetylene experiment was in 2009, when it was found that acetylene actually gave less power than gasoline and was prone to knocking under its explosion, but it did actually work, and there's a great deal of interest in acetylene, particularly during fuel crises and despite the inherent danger. Now, it really doesn't matter what you feed into an engine. If you can get it to expand with some energy, you can run an engine from it. So instead of feeding in a liquid fuel, what they did was powder up coal dust, spray the coal dust in with some air and burn that. Now that actually worked. It worked so well that a whole series of engines were built based on coal dust. Perhaps I don't know, the most hilarious engine was the gunpowder engine. I just love it. The first ever gunpowder engine consisted of strapping a cannon onto the back of your car and firing it. But you imagine the drive that must have been. You shoot off, slow down, shoot off, slow. It just must have been terrifying. Anyway, it did move on from that. It moved on from that to injecting the gunpowder in little shots into a piston. But again, you've got to think that knocking has got to be a bit of an issue there, haven't you? In 2006, MythBusters, Season 4, Episode 25, took this on board and decided to see if you could run an engine on gunpowder. And they tried 3 engines from various designers through time. The first one was Christopher Huygens. Christopher Huygens essentially put a piston in a cannon. He put 15 ounces of gunpowder in the bottom of a cannon. They would fire a piston up, valves would open to let the gases out, and so a vacuum was created, and that vacuum would then be pulled back down, and that pulling back down could lift something. Huygens claimed he could lift 6 boys with 15 grams of gunpowder, something around about that. Now there's several replications of that, and all of them have failed because they couldn't get the piston seal. Huygens claims to have built a couple of the engines, but it was quite questionable, and MythBusters tried one and it failed. Now the second one they tried was by somebody called George Cayley. George Cayley was into aviation, and he was really worried about the power to weight ratio of steam engines when trying to run aircraft. So he designed a different kind of gunpowder engine, where essentially there were 2 cylinders, and you set off the gunpowder in one cylinder, and it was supposed to expand and then reciprocate an engine. Again, MythBusters tried this and found that the thing just blew to pieces, and they marked it as busted. And the last one that they tried from history was one by Thomas Paine, and Thomas Paine went a different way. He created a sort of a water wheel, and the MythBusters version, what they did was effectively shoot a shotgun at the water wheel to see if it would turn. Paine actually put the gunpowder into little cups on the wheel, set them alight, and it was supposed to spin around like a Catherine wheel. Again, there have been no examples of that built, so all of these engines were theoretical engines, or people claiming they were, but no evidence of their claim being true. The final thing MythBusters did was try to run an ordinary engine by just blowing the gunpowder into the cylinder and trying to see if it would turn, and they failed. So they marked that whole thing as busted. Now, I was a bit disappointed by that, actually, because I think that they approached it badly, and I don't think they got the right result. And I was thinking about taking up that challenge to see if we could make an engine that could run on gunpowder.
And that's when I came across Charlie Macklin's engine. What he did was take a normal oscillating steam engine, like this one, and attach it to a chamber. The chamber had a filter in it for removing smoke particles, and a charge port for loading the gunpowder and a way of electronically firing it, which was just a spark. When he fired the gunpowder, of course, it burnt and expanded, was filtered and was pushed into the steam engine, and that ran the engine. The problem for MythBusters was they used store-bought gunpowder, and modern gunpowder burns far too quickly. Charlie made his own. It still burnt quickly, but much more slowly than modern gunpowders, and that was able to run the engine. So to make a gunpowder engine, only 3 things are needed: a small brass oscillating steam engine, a chamber capable of taking the pressure, and the right kind of gunpowder.
Gunpowder was first mentioned in the Chinese histories in 904 AD when it was used in warfare, and it stayed there until about the late 1300s when it made its way to Europe. Now, it wasn't until about 1758 or so, certainly in the late 18th century, that the formula for gunpowder was actually regularised. Prior to that, everybody mucked around with the recipe because it's made up of 3 very basic things: sulphur, carbon, potassium nitrate. Now, each of these things contributes its own bit. This is the fuel. This is the oxidizer, provides oxygen so that this can burn, and this burns as a charcoal briquette. It's what you use on your barbecue. This one is part fuel and part to reduce the temperature of ignition. As this stuff starts to burn about 400 degrees centigrade or so, this is much, much lower. So the role of sulphur is to be a fuel and to reduce the ignition. So you don't actually have to have sulphur in gunpowder, but traditionally you do, and for that reason. And the ratios are 75% of this, 15% of this, 10% of this by weight. Now if I were to take these three things and just chuck them in a bowl and mix them up, what I would get is possibly the worst gunpowder in the entire world, because this stuff cannot be mixed just like that. You have to get it mixed well. And there are two ways to mix it. One way is a dry method, and that's how you always start with it. You can mix it wet when you wet it down with alcohol, and then you can mix it up and grind it and compress it and dry it and get it into a nice cake and then break that cake up into granules. But you mix it well, and in order to do that we have to make these particles smaller. Now the easiest way to make these particles smaller is with the kitchen blender. Now whenever you read the recipes it always says carbon, but turns out that carbon itself won't do. Best stuff is this stuff, which is charcoal. This is softwood charcoal made from a bit of pine, and it's considered to be the best kind of charcoal to use. If you use pure carbon, it's much slower and much harder to get burning. This stuff is in fact paralysed wood, so it's not all turned into pure carbon. There's little bits in there. And there's something called brown powder where they just use charred straw. If they use charred straw to make brown powder, it burns at a much slower rate and cooler, but it burns. Pure carbon, it's so difficult to use that they don't actually use pure carbon, they use charcoal. Here's my ground up carbon, here's my powdered sulphur, and this stuff, which is saltpetre or potassium nitrate, actually it's really easy to get hold of. It's sold for curing meat, and this is food grade, so really very pure. But you can also buy it as stump remover if you want, and we need to chop that up, because even though it's a fine salt, it's not fine enough. We need to grind that up until it's kind of like icing sugar. Now this stuff's hygroscopic, means it sucks in water from the air, so once you've ground it up you need to drive off the water. You do that in your oven carefully. You'll drive off the water at about 120 degrees centigrade or something like that, and you'll notice I'm using a lot of paper cups and no metal, because although they're perfectly safe at this stage, once we get this done and add those bits together, we don't want any arcing or sparking whatsoever, obviously, because then it'll be gunpowder. Okay, now we've made our three flowers, we can add them to each other. Now I should warn you that the making and storing of gunpowder is extremely dangerous and in some places illegal. So check your legislation, make sure you're a chemist who knows what you're doing, and don't do anything loony. I'm doing this for research purposes because I want it for an experiment. As we know, when that experiment is complete, I will be disposing of this properly and not storing it. So be aware that there are hazards associated with this. 100 grams, which is what's in here, 75 grams of potassium nitrate, 15 grams of carbon and 10 grams of sulphur is actually quite a lot. Now we need to mix it. The easiest way I've found to mix it is add the cups, seal this one cup in on top of the other, and then just turn it alternate. So once it's like this, all we have to do is that. For about 4 minutes or so. Don't shake it vigorously, don't smoke, don't get any static near it, don't get any sparks on it. If you're walking on a nylon carpet in polyester socks, make sure you ground yourself before you go near it, because this is now gunpowder. 4 or 5 minutes later we're ready to take the top off. Now this is the stage in which in the mills where they add alcohol and mill it with non-sparking materials like limestone or lead, something like that, and that was then pressed to take out the moisture, and that was called press cake, and then it was put through a sieve to make particles about the size of corns, and that was called corning. And there we go. There is our black powder, our gunpowder. Now gunpowder is notorious for drawing in moisture from the air, and when that happened on the battlefield it had to be repaired, and you bet your life repairing was not something people wanted to do. So if you want to store this for any length of time, check your legislation, but store it in an airtight container so the moisture can't get in there. The other thing they used to do, of course, was take the corns and to whatever grain size they wanted to use, they would tumble that in some graphite. And the graphite would put a coating on the grains and prevent moisture ingress and also prevent any static build-up. That's why black powder these days has that silvery grey look. So there's a line of our gunpowder. Let's give it a go. Okay, that does create quite a lot of smoke. Now, although we used a regularised mix from the mid-18th century, we got quite a slow burn, which we wanted. And now you want to have different kind of burn rates. If you put a fast burning powder into something like a cannon, all that powder can have burned and the pressure built up before the shot gets out of the cannon, so the pressure is too big and blows the cannon to pieces. If you put a slow burning powder in something like a side gun, then it won't get enough pressure to get a small projectile travelling the velocity that it wants to travel at. So playing around with the burn rates of powders was very important as artillery developed. Because loading some of this early artillery was more of an art than a science. I suspect it still is. But you need different powders at different burn rates, and you can do that by changing the way you mix things, changing the constituents that you put in there. As you mentioned, you can use charcoal, you can use brown charcoal where it's not fully powderized to make brown powder. You can change the grain size. When we did make those grains, the corns we talked about, they can be made in different sizes and ground after to be a range of sizes. They run from fine to coarse. Something like, I think 7F is about 2 millimeters in diameter to 15 millimeters in diameter, something like that, I'm not sure. But they also make cannon shot, which is just solid chunks of black powder with a hole in the middle for expansion. So there's a whole way you can play with the sizes and the ways that you mix and the mixers in there to change that burn rate. But I'm pretty happy with that burn rate as it happens, and that's the one we're going to use. Anyway, I thought I would go through all of that because gunpowder is in fact a fascinating history and we want to use it for an engine. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.